All right, so we just talked about symmetric block ciphers, how they chunk data into blocks and operate on a block at a time. The other type of symmetric cipher is called a stream. And a stream works on a single bit at a time. It encrypts bit by bit by bit. Very, very fast. As a matter of fact, it's really best incorporated with hardware mechanisms, because what happens is, to take advantage of the speed, you need a hardware device that can just spit out ones and zeros quick. Okay? Now, with your stream ciphers, again, one bit at a time, and there are a couple of different ways that stream ciphers can work. A common way is transposition. And transposition is scrambling the characters. Shifting the characters left or right, scrambling them. So, for instance, if the word was the, with transposition, it might be HTE, for instance. So, scrambling the characters. Substitution, pure substitution is replacing one character with another. Okay? And a lot of times we want multiple substitutions, multiple transpositions, but then there's also a process called XOR. And XOR stands for exclusive OR. And let me just show you real quick how XOR works. XOR. So the way XOR works is, let's just say I've got some plain text. And once again, that plain text would be a series of ones and zeros. And then I'm going to have a pseudo randomly generated key. And again, I'm just randomly making these up. But with this particular encryption mechanism, again, it's a stream. So what it does is it uses the key bit by bit by bit to provide encryption. Essentially fairly easy, because when you match up the plain text with the key, where the values are alike, the ciphertext becomes 0. Where the values are different, ciphertext becomes 1. So by following this rule, the plain text is 1, the key is 0, those are different values. So the cipher becomes 1. These two values are the same, 0. Different, 1. Different, 1. Different, 1. Same, 0. Different, 1. And same, 0. So this is a very quick process called XORing, but what it does is it provides encryption bit by bit by bit by bit. And a lot of algorithms that are stream ciphers, many of them use that. The most common stream cipher is one called RC4. And this is used by our wireless protocols, WEP and WPA. Not WPA2, but WEP and WPA. And you can see how very fast this was to provide encryption. You take a key, match it up bit by bit with the plain text. If the two values are different, you get ciphertext 1. If the two values are the same, you get ciphertext 0. So boom, 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 boom. Very quick to encrypt, but also if you have the key, it's very quick to decrypt. Because if you just match the cipher and the key, well, those are different. It's got to be 1. Those are different. It's got to be 1. Different, 1. Different, 1. Same, 0. So it's very quick to encrypt. It's very quick to decrypt. And that's a real advantage of RC4. However, when we gain speed, a lot of times we trade security. So RC4 is not considered nearly as secure as a block cipher like AES. And as a matter of fact, I just said WEP and WPA use RC4. When we went to WPA2, which is really the Wi-Fi protocol we wanted to get to, WPA2, its big change is it went to Advanced Encryption Standard, AES, a block cipher that's stronger and more secure, and that's a big step in the right direction. So that's your stream ciphers, very fast. The only stream cipher you would need to know for this exam is RC4. Okay? There are other RCs. There's RC2 and 3 and 5 and 6. None of those are streams. The only stream cipher I want you to know is RC4. So if you were to see something on IDEA, blowfish, cast, twofish, block, 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 the only one that I need you to know for stream is RC4.